So in this question, we've been given the probability function for a discrete random variable. Initially, we've been asked to determine the value of the constant k. So I'm going to start by making a table. The table is going to be the probability distribution of this discrete random variable. So my top row, as always, is going to be the sample space. It's going to be all of the possible outcomes, and we have 3, 4, and 5. Below, I'm going to substitute into the function that we've been given, and that's what's going to generate expressions for the probability. So the function is kx squared. When x equals 3, that means I have k times 3 squared. So that's going to be 9k. Next, I have k times 4 squared and k times 5 squared. 9k, 16k, 25k. Since we have the sample space, we know that these are all the probabilities. And we know that all probabilities, if they're exhaustive, will add up to 1. So these 3 together should give a total of 1, which generates an algebraic equation I can use to solve for k. We have 50k equal to 1, which means k is 1 over 50. I've actually found the value of k, but, and this is good practice, I'm now going to resubstitute that to get a row of probabilities that don't involve k. A row of probabilities that are constant numerical values that I can use for any further calculation. So that's 9 over 50, 16 over 50, and 25 over 50. Part B asks us to find the expectation of x. This is going to be the product sum of the x values and the associated probability. So 3 times 9 over 50, 4 times 16 over 50, and 5 times 25 over 50. As we work each of these out, that gives us an answer of 216 over 50, or as a decimal, it's 4.32. Next, we're asked to find the variance of x. The first step for the variance of x is to find the expectation of x squared. It's a very similar calculation. On your calculator, you would really just go back to the previous line of working and add a squared to the 3, the 4, and the 5. It's x squared times the associated probability. As we work each of these out, we get a value for the expectation of x squared of 962 over 50. Now, the variance is a combination of these two. It's going to be the expectation of x squared minus the earlier expectation of x squared. So, putting those fractions in, we then get a variance of 0.5776. Okay, that makes sense in this case, that the values were only 1 away from the middle value. There's only a maximum spread of 2, so I would expect the variance to be quite low. So that was actually part 2 of B. It was the same question. Part C, we're doing some coding with the expectation and the variance. With the expectation, all linear operations need to be applied. So multiplying, dividing, adding, subtracting, all of those are relevant. So the expectation of 5x minus 4 is equivalent to 5 times the expectation minus 4. We'll just substitute the expectation we found earlier, and that gets us an answer of 17.6. With the variance, however, we only pay attention to multiplying and dividing, so we can ignore any subtractions. So this is exactly the same as the variance of 5x. When we bring the 5 out of the brackets, it actually needs to be squared. Since the variance is already a squared variable, the standard deviation will be multiplied by 5. The variance is multiplied by 5 squared. Okay, so that gives us 25 times 0.5776, which gives us a variance of 5x minus 4 to be 14.44.